linear programming graphical method given minimization problem. So the symbol that we're going to use is this greater than or equal. You also read this as at least. So when we say at least, pinakamababa, pataas. Example, if you want to have kids and you will say at least 3. So greater than or equal to 3. The minimum number of kids that you will have is 3 going up. So we have this given problem. A pharmacist produces a drug from 2 ingredients. Each ingredient contains the same 3 antibiotics in different proportions. Each ingredient A produces results 80 pesos in cost. Each ingredient B results 50 pesos in cost. The production of the antibiotics is dependent on the availability of limited resources. The resource requirements for the production are as follows. We have this table already as our given. Then, as you notice, ingredient A, in 3 proportion, yan ang ating minimum requirement, 6 for 12. For ingredient A, we need to have 3 antibiotic 1, 1 unit antibiotic 2, 2 units of antibiotic 3. For ingredient B, we should have 1 unit of antibiotic 1, 1 unit of antibiotic 2, and 6 units of antibiotic 3. So the question is, the company wants to determine the quantity of ingredient A and B that must go into drug in order to meet the antibiotics minimum requirements at the minimum cost. So first step, represent the unknown in the problem. You know this already. We should have let X be the what? The quantity of ingredient A. Then let Y be the quantity of ingredient B. So we're done with our unknowns. Then step 2, tabulate the data about the facts if necessary using a table. Okay, so the first column, the materials needed. Then the second column, we have here the ingredient A. Third column, ingredient B. And then last column is the minimum requirements. Let us just copy the givens above. Ayan. Copy, paste. And then ingredient A, we know represented by X. And ingredient B, we know represented by Y. And then we need to write the cost here, cost function below. Each ingredient A costs 80 pesos. So you write 80 and the other one, 50 pesos each. So we're done with our table, summarizing all the given. Then step number 3, we need to formulate the objective function and constraints. So objective function is our cost function in the form of an equation. So cost is equal to 80x plus 50y. 80 times the number of quantity of ingredient A plus 50 times the number of quantity of ingredient Y. Then constraints. So, yung ating each antibiotic, kukuhanin natin yung proportion. Ayan. So, first row, antibiotic 1, 3 units for ingredient A, 1 unit for ingredient B, then 6 ang minimum requirement. So, 3x plus 1y greater than or equal to 6. 3x plus 1y indivisible 1, so just y greater than or equal to 6. That is our first constraint. Then second constraint, antibiotic 2, 1, 1, 4. So 1x plus 1y greater than or equal to 4. Then last column, antibiotic 3, 2 units for ingredient A, 6 units for ingredient B. Minimum requirement is 12. So 2, 6, 12. 2x plus 6y greater than or equal to 12. And we need to write always our fixed non-negativity constraints. So x is greater than or equal to 0. Y is greater than or equal to 0 to emphasize that our answer will just come from the first quadrant because we need to get a positive value for x and y. Then plot the constraints of the LP problem on a graph. Before you plot, you need to get the x and y intercept, how to graph. So let us get the x and y intercept of our constraints. Okay, I will write here x-intercept, then y-intercept. So for our first constraint, we have 3x plus y greater than or equal to 6. So x-intercept cover y. So 6 divided by 3, 2. So 2 comma 0. And then y-intercept cover x. Y is greater than or equal to 6. So ang ating y-intercept ay 0 comma 6. Then, let's proceed to our second inequality. This one. Given by x plus y is greater than or equal to 4. So, x-intercept cover y. We know that is just 4 comma 0. 4 comma 0. And then y-intercept, ganun din, 0 comma 4. And then for the third constraint, we have 2x plus 6y greater than or equal to 12. So, x-intercept cover y. So, 12 divided by 2 is 6. 6 comma 0. Y-intercept cover x. So, 12 divided by 6, 0 comma 2. Okay? Then, let us now graph. So, the inks that I use with the corresponding color, that will be the line that you're going to use, the color of the lines. Okay? First one, purple inks. So, purple line. Let us plot the point in the graph. So, 2006. So, 2012. So, here, 06, 1, 2, 3, 4, 5, 6. This one. Connect the 2 points because 2 points determine a line in geometry. Ayan. So, let us name this equation as 3x plus y greater than or equal to 6. So, 3x plus y greater than or equal to 6. Next one. Let us graph the one that I wrote in green inks. 4004. Let's use green also in graphing. 4004. Yan. Connect. Then name the line x plus y greater than or equal to 4. Lastly, the one that I wrote in orange inks, 6002. Draw a line that will connect the 2 points. And then name the line 2x plus 6y greater than or equal to 12. Ayan. And then, let us now get the intersection of all the lines I drew in this graph. So, pag minimization problem, greater than. So, ang shading natin laging sa kanan. Right side. So, dito sila magi-intersect. Lahat. Now, let us get all the extreme points. This point, this point, this point, and this point. Let us name them. The first one is located in 06. This point is 1, 3. This one is 3, 1. And the last point is 6, 0, which is an x-intercept. Then, we have 4 extreme points. Now, we're done in determining the feasible region. Step 5. Step 6, solve the intersection of the lines. They fell exactly or drop exactly in the corner. So, madali sila ma-distinguish. Then, step 7, substitute the coordinates at the extreme points of the feasible region in the objective function. So, let us now write all the extreme points given by, first one is 0, 6. We have 1, 3. We have 3, 1. And we have 6, 0. Then, Let's recall our objective function given by the cost is equal to 80x plus 50y. And then substitute our ordered pairs, extreme points, with our cost function. The first one, 0, 6. Then we have 1, 3. We have 3, 1. And we have 6, 0. So let us solve. So 80 times 0, 0. 50 times 6, 300. Then 80 times 1, 80 plus 50 times 3, 150 plus 80. That is 230. And then 80 times 3, 240 plus 50. That is 290. And then 80 times 6 plus 50 times 0. Cancel this one. Go for 80. So what will be our answer? As you notice, this will give you the minimum cost, 230, given the coordinates 1, 3. So you will call this the optimal solution or optimum solution. Then this one is our optimal value. Then make a conclusion in step 8. Formulate your decision. Since the coordinates 1, 3 will give the lowest value of 230. Thus, we need to mix 1 unit of ingredient A and 3 units of ingredient B to minimize the cost at 230 pesos. Final answer.